Hello students, how are you? I hope all of you are good. In this video, I am going to start a new chapter, that is 13th chapter of the class 12th, probability. You started learning this probability from the class 10th, and in class 10th and 11th, you studied the basic concepts of the probability. That is nothing but what is meant by the probability and what is meant by the random experiment, what is meant by the sample space, and what is meant by an event. So these all things are already studied in earlier classes. But to study the probability of class 12th, we need all these basic things. So that's why I just want to recall the things which are studied in your earlier class by considering one example, and then we go for the concepts of the class 12th. So here the first question I am going to consider to recall the concepts of earlier class. The question is, a coin is tossed twice. A coin tossed twice. Here coin is tossed twice. When a coin tossed once, we have two possibilities. Either that coin may shows head or tail. So it means this experiment tossing a coin once has two possibilities, means two results. And also we cannot predict its results in advance. When a coin is tossed, we are not able to predict its results, whether that coin shows head or tail. So it means the experiments which has more than one results, which are more than one results, and the experiments in which we cannot predict its results in advance. Such type of experiments are called as random experiments. Such type of experiments are called as random experiment. So here the random experiment is tossing a coin twice. And when a coin is tossed twice, the possible outcomes of this random experiment is either that both the coin shows head, or first coin shows head and second coin shows tail, or first coin shows tail and second coin shows head, or both the coin shows tail. So these are the only possible outcomes when a coin is tossed twice. And the results of the random experiment are known as outcomes. So HH, HT, TH, TT are the outcomes. Why? Because these are the results of this random experiment. And if we write a set of all the outcomes of the random experiment, that set is called as sample space. And sample space is always denoted by the capital letter S. So here the sample space is HH, HT, TH, TT, the set of all possible outcomes of the random experiment. And then let us consider an event. Let's suppose E is one of the event. E is one of the event, and getting both heads. Getting both heads. When a coin tossed twice, considering one event, that event is getting both heads. It means the outcome of this event E is exactly one. That is what H. And observe here, E is this event E is subset of the sample spaces. Event is nothing but subset of the sample space. Subset of the sample space is called as an event. And what is the probability of the event E here? So now what? Probability of the event E. Probability of the event E. Already you know the formula to calculating the probability of an event. Number of favorable outcomes. Number of favorable. Number of favorable outcomes. Number of favorable outcomes of the calculating event E divide by total number of outcomes of the sample space. Total number of outcomes of the sample space. So it means probability of the event E is equals to number of possible outcomes of the event E is 1. So 1 divided by total number of outcomes in the sample space. That is number of outcomes in the sample space is equals to 4. Therefore 1 by 4 be the probability of getting event E when a coin is tossed twice. I hope all of you understood. And one more thing, see here, the probability of each outcome in the sample space. As you know that when a coin is tossed once, probability of getting first head is 1 by 2, and probability of getting second hit is also 1 by 2. It means probability of getting head head when a coin tossed twice is 1 by 4. Similarly, probability of getting head 1 by 2, probability of getting tail is 1 by 2. So therefore, probability of getting this H tail is 1 by 2 into 1 by 2, that is 1 by 4. Similarly, probability of TH is also 1 by 4. Probability of TT is also 1 by 4. So it means probability of getting each outcomes in this sample space is 1 by 4. It means each outcome has equal chance to appear. So hence these type of outcomes are called as, these types of outcomes are known as equally likely outcomes. Equally likely outcomes. Equally likely outcomes. I hope all of you understand it. Equally likely means equal chance to appear. And one more thing here. So as you know that a coin tossed twice is a random experiment. Why? Because it has more than one results and we cannot predict its results in advance. And sample space means set of all possible outcomes of the random experiment. Outcomes is nothing but results of the random experiment, and event is a subset of the sample space, and probability of an event is calculated by using the number of favorable outcomes to the calculating event divided by total number of outcomes in the sample space. I hope all of you understood. And one more thing here, let us consider one more example. So here I am going to consider one more example. So suppose the question is, an unpaired coin is tossed. An unpaired unpaired coin tossed twice. Coin tossed twice. Unfair in the sense abnormal. So here nothing is given, a coin is tossed in the sense it is a fair coin. If nothing is given in the question, it is understood it is a fair coin. So fair coin in the sense normal coin. Fair coin means normal coin. Normal coin means equal chance to appear head and tail. But unfair means that, unfair means abnormal coin. Abnormal coin. It means there is a possibility to get head and tail in different chances. So let's say in this coin, let's say in this question, probability of getting head is 1 by 3 and probability of getting tail is 2 by 3. See here, this is a unfair coin. This is unfair coin. That's why probability of getting head is different from probability of getting tail. And when this coin is tossed twice, when this coin is tossed twice, then possibilities are same thing. If both coin shows head, or head tail, or tail head, or tail tail. So here you can observe here, probability of getting first head is 1 by 3 and probability of getting second head is also 1 by 3. It means probability of getting head head is 1 by 9, and probability of getting head tail, probability of getting head is 1 by 3 and probability of getting tail is 2 by 3. It means probability of getting head tail is 2 by 9. And similarly, probability of getting tail head is also 2 by 9, because 2 by 3 into 1 by 3. And probability of getting tail tail is 2 by 3 into 2 by 3. 2 by 3 into 2 by 3. Answer is equals to 4 by 9. So observe here, probability of getting head head is 1 by 9. Probability of getting tail tail is 4 by 9. Probability of getting tail head is 2 by 9. Probability of getting head tail is also 2 by 9. So it means you observe here, each outcome has different chances to appear. It means these type of outcomes are known as, these types of outcomes are known as, these type of outcomes are known as unequal likely outcomes. These type of outcomes are known as what? Unequal, unequal likely outcomes. Unequal likely outcomes. I hope all of you understood this thing. And one more thing, let us consider here also one of the event. Let's suppose A is one of the event, and event is getting one head, getting one head, getting one head. And probability of A, before calculating the probability of the event A, let's write outcomes of the event A here. So here the outcomes of the event A is possible outcomes of the event A is getting one head in the sense either head, tail and tail head. Head, tail and tail head. And probability of A is equals to, it is not equal to number of favorable outcomes divided by total number of outcomes because these are the unequal likely outcomes. That's why here to calculate the probability we use the axiomatic approach of probability. We use the theory what? Axiomatic, which is studied in your first PUC. Axiomatic approach of the probability. Approach of the probability. So by this we can calculate the probability of A, and probability of A is calculated by using the summation of probability of getting head tail and probability of getting tail head. So which is equals to, observe here, probability of getting head tail is 2 by 9 plus probability of getting tail head is also 2 by 9 and which is equals to 4 by 9. So probability of getting one head when a coin tossed twice on unpaired coin is 4 by 9 when its probability of head is 1 by 3 and probability of tail is 2 by 3. I hope all of you understood. So these two examples are very important to understand the concept of first exercise of the probability in the class 12th. I hope all of you understood. So let's start the concepts of the second division. First concept of the class 12th in probability is conditional probability. Conditional probability. So observe here what is meant by this conditional probability. So this is also most important concept to understand the upcoming concepts. Now see here, conditional probability means in this probability we need to calculate the probability of one event. Let's say it is E. We need to calculate the probability of event E when the second event F is already occurred. When the event F is already occurred and it is denoted by probability of E by F. So probability of E by F means when we are calculating the probability of event E, he has given one more condition, that what? That is the event F is already appeared. So the meaning of this thing is probability of event E given that event F is already occurred. F is already occurred. Event F is already occurred. But ಇಲ್ಲಿ ತನಕ ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೆ probability of event A or event B or event E, event F, anything it. But in this concept we are calculating the probability of the event A or event E or event Z when the other event is already occurred. So here we are calculating the probability of event E and he has given that F is already occurred. So therefore the formula to calculate the probability of E by F is probability of E by F is equals to probability of E intersection F divides probability of F. To identify the value of probability of event E when F is occurred, we need two probabilities. First one is probability of E intersection F and probability of F. And the formula to calculate the probability of E by F is what? Probability of E intersection F divided by probability of F. So let us consider one example to understand this. So here the example is, so here also I am going to consider a simple example. Suppose a coin tossed twice and find the probability of getting both heads given that at least one head appears. At least one head appears. At least one head appears. See here, in this question, he has given that coin is tossed twice. It means the sample space of experiment is equals to HH, HT, TH and TT. And then you observe here, find the probability of getting both heads. It means we need to calculate the probability of the event getting heads. And here the finding event is, in this probability of E by F, the finding event is E. E is what? Finding event. And what is F? F is a occurred event or given event. So here we need to calculate the probability of getting both heads. Therefore, event E is getting both heads. Getting both heads. And he also given that at least one head appears. So given event is F, and here the given event is, that is F. F is what? At least one head appears. At least one head appears. At least one head appears. So see here, the outcomes of the event E is, outcomes of the event E is getting both heads, means this is the only possibilities, that is head. And outcomes of the event F is at least one head, in the sense greater than or equal to one head when a coin is tossed twice. It means either one head or two heads. And observe here, one head appears in second and third outcomes, that is HT and TH, and more than one means maximum two heads. So head. So these are the outcomes of the event F. But we need the what? Probability of E by F. We need what? Probability of E by F. Probability of E by F. And we know the formula for probability of E by F. That is probability of E intersection F divides probability of F. So here from this second event F, directly we can get its probability and its probabilities. Since this is a fair coin, so nothing is given means it is a fair coin. And probability of the event F is number of outcomes in the event F is 3 divided by total number of outcomes in the sample space is 4. Therefore, probability of the event F is 3 by 4. And also we need probability of E intersection F. So therefore, we need to calculate the E intersection F. Intersection means common elements between E and F. Here the common elements is only one, that is what? Head and head. So head is E intersection F. And we need its probability. And probability of E intersection F is equals to, observe here the number of outcomes in the event E intersection F is 1 and total number of outcomes is 4. So 1 by 4 be the probability of E intersection F. Now substitute these two probabilities in probability of E by F. Probability of E intersection F is 1 by 4 divided by probability of F is 3 by 4. So cancel 4 and 4. So directly we get probability of E by F, that is what? 1 by 3. I hope all of you understood, and this is what? Introduction part. So let us consider some of the NCERT solved examples from your NCERT textbook. Here the first question is, that is example 1, which is solved example. So here the question is, if probability of A is equals to 7 by 13 and probability of B equals to 9 by 13 and probability of A intersection B equals to 4 by 13, then evaluate probability of A by B. So here directly as given that the probabilities, and we need to calculate the probability of A by B. So we know that probability of A by B is equals to probability of A intersection B divides probability of B. And in this question, probability of A intersection B is given, that is 4 by 13, and divide by probability of B is also given, that is 9 by 13. So therefore 13 get cancelled, hence required probability of A by B is equals to 4 by 9 is the answer. I hope all of you understood. So next consider the second question. And the second question is, see here is a word problem and we need to identify the first and second events. So in this question he has given that a family has two children. A family has two children. It means that two children may be baby girls or baby boys. It means the sample space of this question, that is S, is equals to family has two children, in the sense both children are maybe boys, or first is boy, second is girl, or first is girl, second is boy, or both are girls. I hope all of you understood. So these are the possibilities that two children in the families. It may be both are boys or both are girls, or anyone is a boy and girl. So here capital B stands for elder boy, small b stands for younger boy, and capital G stands for elder girl, and capital G stands for younger girl. So and in this question, see here, what is the probability of that? What is the probability that the both the children are boys? What is the probability that the both the children are boys? It means we got the calculating event. What is the calculating event? That is E. And E is what? Both the children are boys. Both children. Both children are boys. And we need one more given event. And here he has given that, sir, directly he has given in this question, given that at least one of them is a boy. So given event is at least one of them is a boy. So here event F is at least one of them, one of them is a boy, is a boy. And we need the probability of A by B value or E by F value. So it means probability of the calculating event E divides probability of the given event F. We know that probability of E by F, probability of E by F, and its formula is probability of E intersection F divides probability of F. So we need probability of E intersection F and probability of F. So here the outcomes of the event E is, so event E is both the children are boys, means B and B. This is the only possibility in event E. And F is, event F is, so observe here, at least one of them is a boy. It means greater than or equal to one boy, greater than or equal to one boy. So one boy exists in GB, BG, and BB has two boys. So it means the possible outcomes of the event F is BG and GB, and both are boys, BB. I hope all of you understood. So here directly we can calculate the probability of the event F. Probability of F is equals to three outcomes are exist in event F. So 3 divided by total number of outcomes in sample space is 4. So 3 by 4 be the probability of F. And we need probability of E intersection F. Now what? E intersection F. E intersection F means common outcomes in the event E and F. That is what, only one common outcome, that is BB. So B. Therefore, its probability of E intersection F is equals to 1 by 4, because one outcome in E intersection F, total outcomes is 4. Therefore, 1 by 4 be the probability of E intersection F. Hence, the required probability of E by F equals to probability of E intersection F is 1 by 4 divided by probability of F is 3 by 4. So same thing, 4 and 4 get cancelled. So required probability is 1 by 3. I hope all of you understood. So this question is important for 2 marks. So asked in your annual examination. So let's start the next question. And the next question is 10 cards numbered from 1 to 10. So here 10 cards numbered from 1 to 10 are placed in a box. There is a one box. In box he has to given 10 cards numbered from 1 to 10 and mixed up thoroughly, and then one card is drawn from the box randomly. So randomly one card is chosen, and it is known that on the drawn card is more than 3. So see here, in a box there exists totally 10 card number from 1 to 10, and from this box, after mixing the cards, he has to choose one card randomly, and it is known that that chosen card has more than 3 number on it. It means it is a given event. The drawn card number is more than 3. And here's one more thing here given, that what is the probability that it is an even number card. So here also same thing, one of the given event is exist and one of the calculating event is exist here. So here the experiment is one box has 10 cards number from 1 to 10, numbered from 1 to 10, 7, 8, 9, 10. So numbered from 1 to 10, and after mixing that 10 cards, he has to choose one card randomly, and that chosen card shows number more than 3. Number more than 3. And his question is, what is the probability that it is an even number? What is the probability that it is an even number? It means sample space has totally 10 cards. Sample space has totally 10 cards numbered from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And observe here, his question is, what is the probability that that drawn card is an even number? So it means calculating event we considered E, and E event is drawn card. Drawn card number is even. Number is even. And given event, that is F. See here he has given that it is known that it is observed that, and it is given that all are same. It means they are the given events. It is known that the number on the drawn card is more than 3. What is the given event here? Number on drawn card. Number on drawn card. Number on drawn card is more than 3. And also here we need to calculate probability of E by F. Here we need to calculate what? Probability of E by F. See here, and we know the formula. Probability of E by F is equals to probability of E by F is equals to probability of E intersection F divides probability of F. So to calculate the probability of F, just write the outcomes of the event F, and to calculate probability of E, write the event outcomes of the event E. And here the outcomes of the event E is, see here, drawn card number is even. So how many even numbers are exist on the cards? 2, 4, 6, 8, and 10. So these are the possible outcomes: 2, 4, 6, 8, and 10. So these are the outcomes of the event E, and the outcomes of the event F is equals to number on the card as more than 3. More than 3 means it may be 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, and 10. 4, 5, 6, 7, 8, 9, and 10. So by observing this, directly you can write the probability of event F. So F has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 outcomes in event F, and total outcomes are 10. So 7 by 10 be the probability of the event F. And we need probability of E intersection F. So now we need E intersection F. E intersection F means common elements. So common elements means even numbers exist on both the events, that is and more than 3. That is what? 4, 6, 8, and 10. So therefore common elements in E and F is 4, 6, 8, and 10. Therefore probability of E intersection F is equals to 1, 2, 3, 4. So 4 divided by total outcomes is 10. So 4 by 10 is the probability of the E intersection F. Hence the required probability of E by F is equals to probability of E by F is equals to probability of E intersection F is 4 by 10. 4 by 10 divided by probability of F is 7 by 10. 7 by 10. Similarly, 10 and 10 get cancelled. So required probability E by F is equals to 4 by 7. I hope all of you understood. So let's start the next question. And the next question is, in a school there are 1,000 students. In a school there are totally 1,000 students, out of which 430 are girls. So first thing, number of outcomes in the sample space is 1,000, and out of that 430 girls, means remaining are boys. It is known that out of 430 girls, 10% of the girls are study in class 12. Out of 430, 10% of the girls, 10% of the girls studying in class 12. So 10% of 430 studying in class 12. It means totally how many girls? 10 divided by 100 into 430, 0 get cancelled, and 10 and 10 get cancelled, which is equals to, so 43 girls, 43 girls are studying in class 12. Totally 43 girls are in class 12. And now see here, what is the probability that student chosen randomly in the class 12? So one student is choosing from the class 12. This is a calculating event, and given that the chosen student is a girl, that chosen student is a girl is a given event. So see here the calculating event is, that is E event is student chosen from the class 12th, or student in a class 12, student in class 12th, student in class 12, and given event. So given event is nothing but directly as given that given that the chosen student is a girl, that selected student is one of the girl. So chosen student is a girl. I hope all of you understanding. Again, we need which probability? Probability of E by F. Probability of the one event when other event is given. That is probability of E by F, which is equals to probability of E intersection F divides probability of F. I hope all of you understanding. Now probability of the event F. Probability of event F. So F is what? Chosen student is a girl. Chosen student is a girl. So out of 1,000 students, totally 430 girls are exist. So therefore, probability of choosing a girl is 430 divided by 1,000. 430 divided by 1,000, which is equals to 43 divided by 100. We may express it as 43 divided by 100. And also we need probability of E intersection F. Now what? Probability of E intersection F, which is equals to, see here, E is what? Event E is a student of the class 12th. And F is what? Student is a girl. It means common girls in event E and event F are nothing but class 12th girls. So see here, event E is a class 12th student and F is a student is a girl. It means common elements in E and F, are common students in E and F are nothing but girls in class 12th. The girls which are studying in the class 12th are exist in the E intersection F event, and we already calculated how many number of girls are studying in the class 12th, that is 43. So it means these 43 girls are exist in the event E intersection F, and its probability is 43 divided by 1,000. 43 divided by 1,000. I hope all of you understood. So now the required probability of E by F is equals to probability of E intersection F. Probability of E intersection F, 43 divided by 1,000. 43 divided by 1,000 whole divided by probability of F is nothing but 43 by 100 or 430 divided by 1,000. Easy ಆಗುತ್ತೆ calculation ಮಾಡೋ. 430 divided by 1,000. So here 1,000 and 1,000 get cancelled. So probability of E by F is 43 divided by 430, and 43 ones are 43 tens. So 1 by 10 is the required probability probability of E by F. I hope all of you understood this.